All right, guys, it's me again, Miss Barber. This time I'm working with with PreAlgebra. So what we're going to be working on is we're going to work on box and whisker plots, which is something we didn't get to. It's the one skill we didn't get to before all this craziness happened. So what I'm going to be doing is I'm going to be walking you through how to create a box and whisker plot, and then how to read the information that you have. Now, this is going to take some patience. You have to pay attention to details when you do this, because box and whisker plots have a lot to do with making sure you get all your information in order and finding the middles of things, because we're looking for medians. In math, when we talk about averages and stuff, we're not always talking about think of as the average. The average is, when we add everything up and divide by how many pieces we have. That's called the mean. We've done that for a long, long time. What's my average? What's my grade? Well, I add up all your grades and divide by how many ever grades you have. That's how it's worked, right? But what we're working with today, and when we work with box and whisker plots, we work with medians. Now, most of the time when you hear the word median, you're not thinking about math at all. I know this. You're thinking about that strip of grass down the middle of the road. That's called the median. That's the middle of the road. And the median for us mathematically is the middle of our data. Not the average of all our data points, but the middle piece. So that's where we kind of start from with our box and whisker plots. But we have to know what a box and whisker plot is before we can, do stuff with it. So these notes were uploaded into the Google Drive for our classroom. If you go to the classroom page, and if you don't know how to get to the classroom page, you need to email me, let me know, and I'll email you back and give you the codes, okay? But this is going to be posted on YouTube. When I'm done with it, it will be under Mrs. B Teaches Me. That's the YouTube channel. I know it's really, really, catchy and everything, but my 16-year-old thinks it's horrible, but that's okay. So what we're going to do is we're going to talk about box and whisker plots. And before we can really talk about them, we have to know what they are. And a box and whisker plot is a way to display data on a number line by organizing it into 4 sections. Now, when we do this, it's going to look like this, okay? Now, this piece right here is where we start from. That's where everything starts from. That's called the median. And then we have other key terms that go around it. We have the minimum value. Now, what does minimum mean? When we think about minimum, what are we thinking about? We're thinking about the smallest possible piece of the pie, smallest possible piece of information out of what we have. So that's where we're going with this. Okay. Now, so I lost my window. Okay. So the minimum value is the smallest value. And most of the time we just shorten it to MIN for minimum, okay? The lower quartile is the median of the lower half. And we call the lower quartile most of the time Q1, okay? The median is the middle value. So if I put everything in order from smallest to largest, and then I count in, the median is the number in the middle. okay? And we always put this in order from least to greatest. Okay, now the upper quartile is also called Q3. Okay, it is the median of the upper half. Okay, and then of course the maximum value, the maximum of anything is the what? It's the most we can have. So the maximum of our data set is the largest value in our data set. Okay, now, what in the world, y'all are thinking, I know y'all, what in the world is a quartile? Well, let's think about it. What does the word quartile have in it? What clue would Miss Bunn have us looking for in the word quartile? Right here. What does that right there mean, lead us to think about? Quartile. What's another word that starts with that quart? What about quarter? What does this quart mean? This is our prefix for the number 4. Quartiles are the 4 sections that make up a box plot. Okay, each quartile is 25% of our total data. That's going to be important when we start drawing conclusions from our box plots. Okay, now the other thing we talk about when we talk about box plots, besides their quartiles, is what we call their interquartile range. And you're going, I don't know. Now let's think back to it. When I'm talking about data, I'm talking about information pieces, and I talk about range, I'm talking about the difference between the largest number and the smallest number, right? The range, how many numbers it covers. Well, when I talk about the interquartile range, I'm talking about that little part of the box that is covered between the lower quartile and the upper quartile. So the interquartile range, bless you, honey. Interquartile range is the range between the lower quartile and the upper quartile, or how long that box actually is. So the range between the lower and upper quartiles. Which means what we are going to do is we're going to take Q3 and subtract Q1 to get the interquartile range. And most of the time when they talk about interquartile range, they will actually, instead of writing that out, they'll call it the IQR. Okay, that's why we did that. So the easiest way to figure this stuff out is to actually dive in and do one. So let's look at our first example here. We have our data sets, we have our number line, and then it's asking us for all kinds of crazy stuff. So the first thing I want to do is I want to take this data set and I want to organize it so that it's from the smallest number to the biggest number. So what I'm going to do is I'm going to look at it, and my smallest number is right here, 50. So I'm going to write that down first. Then I'm going to look. I got 55 and 58. Okay. And then I've got 60 and 62 and 68. And then I have 70. Oh, wait a minute, I forgot one, didn't I? Let's back up. I forgot 64. I got to go back and find 64, put it in. So I've got 64, and then 68, and then 70, and then 72, and then 76, and then 84 and 92. That's a lot of numbers. I almost ran out of room here. Now that they're in order from least to greatest, I need to find out where the middle is. The easiest way to do that is to count. So start from the outside, count in. 1, 2, 3, 4, 5, 6. Oh, there are 2 numbers in the middle. Now, if we remember back to, say, Math 6 and Math 7 when we talked about finding the median, because we found median before. When we talked about finding the median, what we talked about when there are 2 numbers in the middle, we have to add those 2 numbers and then divide by 2. So I'm going to take 64 and 68, add them together, divide by 2, and so our median is 66. Okay, now I'm going to look at my bottom half, and I'm going to find the middle of that. I'm going to start here, and I'm going to start from where I drew my arrow in the exact middle. I'm going to count in 1, 2, 3. Run across the same problem again. I have 2 numbers there. So what I'm going to do is the same thing again. I'm going to do 58 plus 60 divided by 2, and that gives me 59. Okay, this is my Q1, my lower quartile. Not finished yet. Now I have to find my upper quartile. So I look at the top half of my information and I count again. 1, 2, 3. That's 2 numbers again. So I'm going to have to take their average. 72 plus 76 divided by 2 is 74. Now, this is my Q3. Now I can fill out some information before I start to draw my picture. My smallest number, my minimum, was 50. My biggest number, my maximum, is 92. My number in the middle, my median, is 66. My lower quartile is 59. And my upper quartile is 74. Well, what does that have to do with drawing a box on a number line? Everything with how the box is structured. Now, the first thing we have to do is figure out how we want to do our number line. And I struggled with this when I worked on it earlier because I got to go from 50 to 92. That's a pretty big span. Now, I don't know how many boxes I have, but I probably want to go from 50 to 100. So let's see, if I did 100, if I went by 2s, that's not going to work. 10 would squish it up too much, so let's go by 5s. 100, that would make 90 here, 80 here, 70 here, and 60, and 50. Oh, it has actually ended up being a little bigger, but that's pretty much the scale I needed. Every mark to be 5 or every 2 marks to be 10. Now, let's look at the information we had. The median, or the middle of my information, is at 66. Well, that's where I'm going to start my box from. At 66, so we're talking about like right here. I'm going to draw a little line. It's, you know, and this is kind of an estimate because I don't have all my little tick marks in there. I'm just kind of close. Now, my lower quartile was at 59. So I'll put another line there. And then my upper quartile was at 74. So I'll put another line there. Now, once I have those 3 lines, those are the 3 pieces that make my box. But is that all the information that I was given? No, I had a minimum, a maximum, plus my quartile pieces. So now how do I mark my min and my max? Well, my minimum was 50, which means it has to stretch all the way down to 50. But do I want to draw a box that big? Not really. So I'm going to stretch a line from my minimum to connect it to my box. Well, my maximum's 92, which is all the way out here. So now I'm going to draw a line to connect it. Now, this is why most people call box plots box and whisker plots, because I have my box in the middle and my whiskers that go out to the ends. Now, this is the same process every single time. The first thing you're going to do is you're going to put things in order. And then the second thing you're going to do is find the median. Okay. Then we're going to find Q1. That's the middle of the bottom half. Then we're going to find Q3, which is the middle of the top half. Okay. Then we're going to draw our box. And we're going to use Q1, the median, and Q3. And then we're going to draw our whiskers, or we're going to connect the max and the min, the maximum and the minimum, to the box. Okay, so that's the basic mechanics of creating a box and whisker plot. Now, there's all kinds of cool information we can get from a box and whisker plot. So let's look at question A. What is the range? Well, we talked about it a minute ago. The range is the biggest and the smallest subtracted from each other. So the range is the maximum number minus the minimum number. So I'm going to have 92 minus 50, which is 42. So if I were to lay this out on a number line, I would have to take 42 steps to get from the smallest number to the biggest number. That's pretty much what range is. But what if instead of asking you what the range is, I ask you what the interquartile range is? Well, that changes the numbers I have to subtract. The interquartile range is just the size of the box, not the whole graph, just the box. So that in that case, I have to do Q3 minus Q1. So in this case, that would be 74 minus 59. Math's a little harder there. 14 minus 9 is 5. 6 minus 5 is 1. So that box, even though the entire thing is 42 steps long, that little box is just 15 steps long. Okay? So that's the kind of things we look at. Now it says, what percent have a resting heart rate less than 66 beats per minute? Well, 66 beats per minute is my median. So how many sections of this graph are smaller than 66. Well, I have this section here and this section here. Each of these sections is worth 25%. And we know the median is the middle, so we know that 50% of the people surveyed have a resting heart rate less than 66 beats per minute. Using that information from our graph. So now let's look at the next one. What percent have a resting heart rate of no more than 74 beats per minute? Well, 74 beats per minute is here. It's Q3. Now, if it says no more than 74 beats a minute, am I talking about smaller than 74 or bigger than 74? No more than. That means 74 is as big as it can be. So I'm talking about everything smaller than 74. Well, let's look at our box and whisker plot. We have 1, 2, 3 sections that are smaller than 74. So that's 25 plus 25 plus 25. So 75% have a heart rate that is no more than 74 beats per second, or per minute, sorry. 74 beats per second, we'd have a problem. All right, so then let's look at the next one. What percent have a resting heart rate between 50 and 59 beats per minute? Well, let's look at our picture. Here's 50, here's 59. This is one section of our graph. Each section of our graph is worth 25%. Okay, so what percent have a resting heart rate between 66 and 92? All right, here's 66. Here's 92. How many sections did we cover? We covered 1, 2 sections. So that is 50%. These are the kind of questions we use when we're doing box and whisker plots. Excuse me. Box and whisker plots help us, give us a nice little quick visual to read. Okay, so what I'm going to do is I'm going to put a piece of information up and I'm going to give you about 5 minutes to see if you can go ahead and sort through it and create this on your own. For those of you that go to the Google Drive Classroom for us, or the Google Classroom, and then go to the Drive for our classroom, these are in there and you can go and you can copy these notes onto your notes and you'll find these. So now I want you to look at this information right here. And I want you to take the next 5 minutes and create the box and whisker plot for this piece of information for number 2, and then fill out all your key information about minimum, lower quartile, median, upper quartile, and maximum. Okay? Okay, guys, let's look at this and let's go through our steps. Step number 1, put them in order from least to greatest. So let's look. Going through here, my smallest number is 0. Okay. Then I have 2. And look, I have 2 number 4s. So I actually have to write it down 2 times. And then let's see, 4, I have 1, 2, 3 7s. And I have a 9, a 10, and an 11. So now all my data is in order from least to greatest. The next thing I want to do is find my middle, find my median. So I'm going to count in 1, 2, 3, 4, 5. Let me make sure I did that correct. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these 2 are in the middle. Well, what do you notice about those numbers? They're both 7. So 7 plus 7 is 14 divided by 2 is going to take me back that my median is 7. Okay. Now let's find our lower quartile. I'm just going to look at the bottom and I'm going to count into the center. 1, 2. Very nice. There's an odd number there. So when I count in, 4 by itself is my middle number down there. So that's my quartile number 1, my lower quartile. Do the same thing on the top. 1, 2, 3, 1, 2, 3. 9 is my number in the middle, so that's my upper quartile. Now, when I look at this, I now have my mean, my median, my lower quartile, and my upper quartile. And now let's look. Smallest number is the minimum. Biggest number is the maximum. Fill that information in over here. My minimum is 0. My maximum is 11. Let's see. I do this 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I actually have enough spaces. That is awesome. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's awesome. So now I can draw my picture. My median is at 7. So 5, 6, 7. There's the center of my box. My lower quartile is at 4. My upper quartile is at 9. So there's my box. My minimum is at 0. My maximum is at 11. And once I have all that done, my picture is done. So that's how we create a box and whisker plot from our information. Now, is every question going to be about create this box and whisker plot? It's not. Now, there are a couple more on this page that you can practice with when you have your own paper, but we need to go on and look at what happens when we're given a box and whisker plot and then asked to come up with information or analyze the information that we've been given. So let's look at this question down here. It says, the box and whisker plot below shows the test scores of a group of 24 students. Okay, so we know we got 24 students. It says, what is the median score? So if I'm going through and I'm labeling this is Q1, that's the median, that's Q3, this is the min, and this is the max. Okay. So the median score is right here, and if I take this line and I go straight down here, that is an 80. Okay. What percent of students scored between 70 and 85? Well, let's look. Here's 70, here's 85. That's my entire box. That's 2 sections of my graph. So how many kids scored between a 70 and 85? Well, the box represents half my information. So 50% or half the people scored between 70 and 85. Okay. How many students scored between 45 and 85? Well, let's see. Here's 45. Here's 85. How many sections of the graph does this cover? It covers 1, 2, 3 sections. Each section is worth 75 or is worth 25%. So 25 plus 25 plus 25 is 75%. If Kate got in there with 87, how did she compare with the rest of the class? Well, where would an 87 fit? An 87 would be like right here. So are there a bunch of different things we could say about Kate and her grade? Well, which quartile is she in? Which section of the graph is she in? She's in the top 25% of test scores. That's what knowing her score falls on this line tells us. So that means she scored better than at least 75% of her classmates. Are there other things we could say? Sure, but those are the 2 primary things we're looking at. Where does she fit in the overall scheme of things? Now, I'm going to put another question up, or another series of questions up, and I'm going to give you about 5 minutes to see if you can figure out the answers to that section, okay? So here we go. Y'all are looking at number 4. If I can make it fit on my paper. So it says, the fuel efficiency in miles per gallon of a group of cars is shown below. What is the interquartile range? What is the percent of cars, or what percent of cars have a fuel efficiency greater than 20 miles per gallon? What percent of cars have a fuel efficiency less than 26 miles per gallon? So I'm going to give you about 3 minutes to answer those 3 questions based on the picture you have. Okay, guys, so the last piece I'm going to go over for today, because I've been working for quite a while now. So let's look at this. What is the interquartile range? Well, we know to find the interquartile range, we have to take the top end of the box minus the bottom end of the box. So the top end of my box is here at 30, and the bottom end of my box is at 20. So I'm going to do 30 minus 20 and get 10. Okay, and it says what percent of the cars have fuel efficiency greater than 20 miles per gallon? Well, 20 miles per gallon is right here, and greater than means bigger than. So I have 1, 2, 3 sections of the graph, which means that 75% have a fuel efficiency greater than 20 miles per gallon. What percent of cars have a fuel efficiency less than 26 miles per gallon? Well, here's 26 miles per gallon, and I've got 1, 2 sections smaller than that, so 50% have a fuel efficiency less than 26 miles a gallon. And this is pretty much what we looked at. Now, tomorrow, we're going to look at this some more, and we're also going to look at comparing more than one box and whisker plot and what you can do with that. So take your time, be careful. Work through a couple of these examples in the notes. Work through finding the, creating your box and whisker plot, and then work through doing some of these analysis. If you're looking at your notes and you want to know where to stop, question number 8 is the last one you should work on, because I'm going to start with question number 9 tomorrow. As always, on Mondays, I do office hours from 1 to 4. And on Tuesday through Thursday, I do office hours from 9 to noon. 9 to 10 is Algebra 1, 10 to 11 is pre-algebra, and then 11 to noon is questions in general. So guys, until we see you next time, good luck.